So we didn't talk about managing complexity when we were talking about structuring code. This is a big one as soon as your code gets to be more than one file. So there's a couple of things I want to throw out. The main one I want to talk about is this design patterns, and that bridges nicely to the web stuff. So this is the stuff you've already heard me talk about. It's easy to remember less, right? This is the reason that we separate things into separate files, into separate classes, into separate folders. In computer science, the example is often abstraction, right? So abstracting yourself one away, like I did when I made that object that wrapped up the election results. Suddenly I was able to say, hey, load this. I don't care how you load it, just load it. Count it. I don't care how you count it, just count it for me. That's the level of abstraction. And you find yourself moving up. The higher you are, the easier it is to do complicated code, right? So deciding when to abstract something away, when to wrap it up in a nice box that you can then use is a subjective sort of decision you get better at over time, okay? Simplifying assumptions, a big one that you'll see when we talk about Rails today, which is a web framework. Making assumptions for yourself about sort of normal things is really helpful. Like if you decide for yourself that you're always going to store your logs in a folder called logs, your life will just be easier, right? If you decide that you're always going to have API calls wrapped up in a package that says API something, your life will just be easier. It doesn't matter what those decisions are if you're just coding for yourself. As soon as you're using libraries, you want to merge your assumptions, but make some simplifying assumptions so that you can just quickly come up with answers to things so you don't have to think too much. That cognitive load is a big deal. So conventions, use conventions. Oh, I'm always going to look for this here, so I should just systematize it, okay? Readability is one I've already talked about, like commenting. Remember your primary audience for your code and your comments is yourself 6 months from now when you're trying to write your thesis proposal or something. So you will be busy, you will be distracted. Write code for yourself 6 months from now. I've said it in every class. I will continue to say it in every class. I will show examples in situ. 2 reminders. Refactor constantly. Refactoring is the art of visiting code that you've already written that works and reorganizing it so it matches the model of your software that's changed. Right? So when you start writing your software, you have a set of assumptions about the way it's going and the way to architect it. And they use that word a lot, software architecture, right? Like building the structures that will contain your code. You make some guesses about what will work. And then a couple months down the line, it's really important to revisit those guesses and change them if they don't seem right, if they don't match anymore. And that's when you go back to code that's still running and you change something about it, whether it's moving it to a package that makes more sense, naming it something different. And that's when it's really helpful when you revisit that code and change it, that you have some unit tests to run to make sure you didn't break things, right? So refactoring is something you want to be doing constantly, because if you're suddenly 6 months down the line and you haven't revisited the assumptions about the architecture you made in your old code, you're going to go back to your old code and you have to change something. You're going to be like, oh crap, I don't even call this thing anymore, right? If you've changed report to record, suddenly your code doesn't make sense. You're like, oh, I call this records now. What the hell? Why am I calling it this? So that's refactoring described on a very small scale. Do it a lot. That immediately jumps into these IDEs. So the idea that we constantly program in text editors is kind of an antiquated notion, right? Like me saying, hey, use Sublime Text for everything, that's kind of old school still. There are really nice development environments, which is basically an application you load up that is built so that you can write and run code in it very quickly in specific languages. And it makes life very easy. You'll see some of those today and on Wednesday when we look at the... so this is what I want to talk about more, design patterns. So design patterns it came from the realization that when people were architecting software, they were running into similar types of problems. So, oh, we should have a pattern for solving this, and then we can talk about those patterns so we can increase best practices. There are also anti-patterns, like poor solutions that are very commonly used to standard problems. So what's an example of that? So a singleton is an example of that. The idea, a singleton is the design pattern where you want sort of one version of an object, and you always want it to be that copy. You don't want multiple instances of it. You just want it to be one thing, right? So a good example of a singleton is like, you can treat your database as a singleton, right? Like you got one database. Anytime you want to get a connection to it, you can ask that one, hey, give me a connection to you, right? And it can manage giving you that, right? But in a standard web app, very simple one, you're going to have one database that you want to treat like that. So that's the singleton pattern. A factory is the idea that you're asking for instances of something. So a factory, what does a factory do? It produces copies of the same thing, right? So a factory is a standard way to approach asking something to instantiate itself. So give me a copy of yourself set up, ready to go. So that's the factory pattern. The names of these aren't as important as realizing that there are standard solutions to a lot of things that you run into. So workers or a thread pool, the idea that you have limited resources and you want to optimize how you're using things. So say you have a whole bunch of records coming in from reports from some sensor you have in the field, right? So you have sensor in the field, it's sending stuff to your web server, right? And your web server is getting all these connections, and it's got to save all the data as quick as it can, right? Because you don't want to get stuck with a backlog. You can't keep on just like shoving stuff into the database, because at some point it's going to run out of resources. It won't be able to handle 10,000 things at once. So what you do is you basically set up a bunch of workers that are ready, and they're sitting there. So you have, I'm going to talk about these together, a pool of workers where you have like 15 workers sitting there. And their job is to take sensor data, clean it, and save it into the database, okay? And you have 15 of them just sitting there, all allocated, ready to go with their own memory, super happy. When you get a new record coming in, you say, hey, give me a worker, deal with it. And the worker does its thing, and there's 14 available, right? And then when it's done, it comes back, and there's 15 available in that pool of workers. And new records come in, and you keep on going, right? So when all 15 of them are busy, it's going to say, hey, I don't have anything right now. So you need to queue up those records, right? And then when one is free, it'll grab it off the front, right? And it'll deal with it. So it'll deal with it like a queue. And then when more come in, your queue is just getting longer, and your workers will just keep going as fast as they can. But when your input slows down, they'll be able to deal with the backlog, right? So that's sort of a standard approach. So when you're looking for, if you run into that problem, you should go find a library that does that for you. There's tons of them that set up workers for you. There's tons of them that there's like whole software packages that are built to deal with a queue and hand them off to workers, right? So this is like a standard design pattern that people come up with, that there's well-tested, reliable libraries that can do stuff for you. So you don't need to deal with it. So this is an example. These are some other patterns. I encourage you to check out. So this is this sort of this book that was a really big deal when it was written by this group that was so important that they got a nickname. They called them the Gang of Four. And they wrote this book, this design pattern book. If you're really into that stuff, you should check it out. There's also just a wiki where you can look at the standard top 10 design patterns to get a sense of what these solutions are for, okay? So I sped through that, but